All right, kids, it's time for another lesson. Today we're going to be doing Chapter 4, Lesson 7, Linear and Nonlinear Functions. So our learning objectives are to determine whether a function is linear or nonlinear given a table, a graph, or an equation. So just for starters, let's get our brains thinking. Is this graph linear? What does it mean to be linear? Well, for those of you who think the answer is no, you're correct. This is non-linear. And we're going to take a look at why in the next few slides. So first, add these notes to your math notebook. We have linear functions and nonlinear functions. A linear function is a graph that is a straight line with no bends at all. It's straight in one direction. So even though this one on our previous slide is straight, notice there is a bend. It cannot have bends. It cannot have curves. A linear function is a straight line. In an equation form, you're going to have y equals something x. It might have a number at the end, but notice there are no exponents. Y appears once, x appears once. They are not being multiplied. They're separate. In a table, we've done a whole lot on linear functions. It has a constant rate of change. So notice the x values change by the same amount each time. The y values change by the same amount each time. We calculate slope. So linear functions is something that we're already familiar with. Nonlinear may be a curved line, may be a pointed line like we saw over here. Most often, you're going to see a curved line. Typically, an equation that has an exponent, any equation that has an exponent is going to be nonlinear. Another example of an equation that would be nonlinear would be one with absolute value. So in the absolute value symbol, that's actually what this graph is. That's absolute value right there. So that's another example of nonlinear. In terms of a table, we know that it's not linear if it doesn't change by the same amount each time. So notice while x goes up by 3 each time here, y is changing by different amounts. Here it goes up by 10, here it only goes up by 9, here it only goes up by 1. It is not changing consistently, so it is nonlinear.